In this video we're going to talk about trapezoids, and we're going to be able to find what's called a median. We're going to be able to find the length of this median and talk about certain parts of a trapezoid. Let's see what we got here. A trapezoid is basically, well, it's a quadrilateral, right? It's a four-sided shape, but it only has one pair of parallel sides. That's our symbol for parallel. Okay. So it's a quadrilateral, a four-sided shape with only one pair of parallel sides, and those parallel sides are specifically called something. So if we look at this first shape, well, this one and this one, those two sides are parallel, right? Okay, well, let's look at the other side. Which of the sides are parallel? On this one, it happens to be the left and the right side. So when we're looking at trapezoids, a lot of the math involved is going to involve those parallel sides. We've got to be able to locate them. So as long as you can locate two parallel lines, and those being the sides of a trapezoid, you'll be alright. An isosceles trapezoid is kind of unique. You can think of it as similar to an isosceles triangle. In an isosceles trapezoid, these parallel sides, which are called bases, and this is true of all trapezoids, I'm just using this one as an example. The top side here happens to be the base, the bottom happens to be a base here, but if you're thinking that top and bottom are always bases, don't. Let's go back to this example. It was the left and right side that were the bases, the parallel sides are the bases. Don't think of it as just top and bottom. Think of it as the parallel sides are called the bases. These other sides, these sides that are not parallel, those are called legs. So here's a leg, and here's a leg. Now, as you can see, we're kind of talking about two things that have the same name. So in order to differentiate, or in order to tell the difference between the two things, we give them little sub numbers. So we'll call this one base 1. So it gets a little 1 as a sub number. This one's called base 2. And it doesn't matter which is which. It's just whatever you want to call each of them. Likewise with the legs. One of them is called leg 1. The other has to be leg 2. So just ways that we tell the difference between the two similar parts there. Going back to the isosceles trapezoid. Legs in an isosceles triangle are exactly the same. They're congruent. This length is the exact same as that length. And that's not true of all trapezoids, only isosceles. So if you look at here, this leg up here wouldn't be quite the same as this leg. Likewise over here, this leg is not quite the same size as this leg. But in an isosceles trapezoid, it looks all symmetrical and nice and neat. And it's because these legs are the exact same length. And then if you remember in isosceles triangles, we had things called base angles. Well, we have the same thing in isosceles trapezoids. We have base angles, and the base angles are the angles that are the same measurement. They're congruent. So this angle is a base angle. This angle is a base angle because it's attached to the bases. And they're the exact same measurement. Likewise up here, this base angle is the exact same as this base angle. But notice how this is not the same as this one. Only the angles that are attached to one base are congruent. Okay, if they have a different base, they got to be different angles. So just a little quick overview of an isosceles trapezoid. This is where we're getting to the good stuff, though. This is the important stuff. What is a median? Well, a median is a segment, and we can draw it. It's a segment that connects the midpoints of the legs. Midpoints of the legs. So a segment that connects the midpoints of the legs. Well, let's look at this example right here. Find the legs. The legs are the sides that are not parallel. So the left and right side on this trapezoid are going to be the legs. Find the midpoints of those legs, and you can estimate it. So look at the left side. Approximate midpoint is about there. Put a point there. Take a look at the right side. Put an approximate midpoint there on that segment. And there we have midpoints of legs, right? Well, a segment that connects those 2 points is called the median. So if we connect those 2 points, we just drew what's called a median. Okay. Alright, now here comes the math part. The median is always parallel to the bases. That's kind of obvious. So it doesn't do any crazy like diagonal or anything. It's always parallel to the bases right here. And its length. The length of the median is equal to this equation here. The sum of the bases. So if we add our base lengths together and divide by 2, then we get the length of the median. You could also think of the median as being twice the length of the median would be equal to the sum of the bases. And you can do that by multiplying both sides of this equation by 2. And that gets rid of it from this side. So both of these equations here are going to be helpful in these next examples here. So the median length is B, add up your bases, divide by 2, that's our median length. And then sometimes we'll use this little shortcut here to help us. So let's go down to some examples. Okay, in this trapezoid, AB is 25, so that's one base. And its parallel side, DC, is the other base, and that length is 13. And EF is the median. Well, it wants us to find the length, or the value of the segment's length in this example. So 25 plus 13. We add up our bases. There's 25, there's 13. And we divide by 2, and that gives us the measurement of that segment. So 25 plus 13 is 38, and 38 divided by 2, or half of 38, is 19. Okay, so it's not too bad. It starts to get trickier when they give us like the length of the median. If we know the length of the median, but we're missing a base length, that's where it starts to get tricky. We'll get to that in these last two problems. Remember that the median is the segment that joins the two midpoints of the legs. So that point E is a midpoint of AD, and F is a midpoint of BC. So let's use that knowledge to help us with this next problem. If AE is 11, so if that little segment's length is 11, and FB, this segment over here, is 8, then let's find AD and BC. Well, if we know that E is in the middle, then that would make this segment ED the exact same as AE, and that would make the entire segment AD right here. That would make that entire segment 2 times 11, or 11 plus 11. Either way, it's 22. Same thing over here. If this segment BF is 8, that would make segment FC 8, because F is right in the middle. And so that would make the entire segment here 8 times 2, or 8 plus 8. Either way, we get 16. Alright, so the challenging stuff is coming up. This is where we got to use some algebra. It's telling us that AB is 29 and EF is 24. So now it gives us the median length, but not this base length. So use the same equation and use algebra to solve for the missing variable. So AB is 29, that's base 1. We're missing base 2. We know we have to divide by 2, but we know the median is 24. So 29 plus our missing base length divided by 2 should equal 24. Well, if we use algebra, we can solve for b2. If we multiply both sides by 2, then that gets rid of the division by 2 on that side. And it tells us that the sum of the bases is now equal to 48. So if you remember, that was our little shortcut. We'll take it in the next problem. If we add the bases, we know it's 2 times whatever the length is, right? And you can see that happening right here. The sum of the bases is equal to 2 times the median. If we just subtract by 29, then we get our answer for B2, or for segment DC. And it equals 19. Alright, let's try one more. See if I can get rid of all this work here. Come on, we're wasting time here. Oops. Oh, I keep getting rid of the trapezoid. Why? Alright, that's good enough. This time it says AB is 7y plus 6, so a lot more algebra in this one. EF, it tells us, is 5y minus 3. And DC tells us is y minus 5. So it gives us all the values. All we got to do is substitute those values all into our equation. B1, 7y plus 6, plus B2, y minus 5. This is where we're going to use our shortcut, is equal to twice the base. So 2 times 5y minus 3. Alright, well, let's distribute over here. 2 times 5y is 10y, and 2 times negative 3 is negative 6. I'll combine my like terms on the left side. We got 7y plus 1y, that gives us 8y. And 6 minus 5, or 6 plus negative 5, gives us positive 1. Let's combine our like terms on opposite sides here. We could add 7, or sorry, add 6 to get 7. Just jumping ahead there. Add 6 to both sides, that gets rid of that. And now we got 8y plus 7 equals 10y. And subtract 7, nope, we want to subtract 8y. So 7 equals positive 2y, so y equals 2 over 7. So we had to use our knowledge of that equation, b1 plus b2 divided by 2 equals the median length, to solve for a variable using some algebra there. Alright, so that's a basic introduction there to trapezoids and some math you can do with them. Good luck practicing.